Data preprocessing in ML workflow. Data preprocessing in ML workflow. AI beginner level. Introduction. In machine learning projects, raw data is rarely ready to be used directly. Real-world data often contains missing values, incorrect entries, duplicate records, inconsistent formats, noise and outliers. Before training a machine learning model, the data must be cleaned and prepared. This step is called data preprocessing. Data preprocessing is one of the most important stages in the ML workflow because the quality of the data directly affects the performance of the model. Many AI experts say, better data beats better algorithms. Data preprocessing is used in many AI systems such as recommendation engines, fraud detection, medical diagnosis systems, speech recognition, image classification. Understanding data preprocessing helps beginners build more accurate and reliable machine learning models. What is data preprocessing? Data preprocessing is the process of cleaning, transforming, and organizing raw data so it can be used effectively by machine learning algorithms. In simple words, data preprocessing equals preparing raw data for machine learning. Example concept. Raw data means cleaning means transformation means ready for ML model. Without proper preprocessing, machine learning models may produce incorrect or unreliable results. Why data preprocessing is important? Machine learning algorithms expect clean and structured data. However, real-world data is usually messy. Common issues include missing values, inconsistent formatting, categorical data that must be converted to numbers, large differences in feature scale. Example concept. Messy data means preprocessing means improved model performance. Good preprocessing helps models learn better patterns, reduce errors, train faster, improve prediction accuracy. Step 1. Data cleaning. The first step in preprocessing is cleaning the dataset. Data cleaning removes errors and inconsistencies. Common cleaning tasks include removing duplicate records, correcting incorrect values, fixing inconsistent formats, filtering irrelevant data. Example concept. Raw dataset means remove errors means clean dataset. A clean dataset is essential for reliable machine learning results. Step 2. Handling missing data. Datasets often contain missing values. For example, age salary 255000, 30, 356200. Machine learning algorithms usually cannot handle missing data directly. Common solutions include remove missing rows, delete rows that contain missing values, replace with mean, median, fill missing values using the average of the column, replace with mode, use the most common value. Example concept. Missing values means imputation means complete dataset. This process is called data imputation. Step 3. Data transformation. Sometimes data must be converted into a format that algorithms can understand. Examples include converting text to numerical values, normalizing numbers, scaling data ranges. Example concept. Original data means transformation means ML-ready format. Data transformation helps algorithms process information more effectively. Step 4. Encoding categorical data. Machine learning models require numerical input, but many datasets contain categorical values such as city, Toronto, Ottawa, Montreal. These values must be converted to numbers. Common encoding methods include label encoding, assign numbers to categories. Example, city code, Toronto 0, Ottawa 1, Montreal 2. 1 hot encoding. Create a separate column for each category. Example concept. Category values means encoded numeric features. Encoding allows algorithms to process categorical data. Step 5. Feature scaling. Different features may have different numeric ranges. Example. Feature range. Age 18 to 60. Income 200,000. Large differences in scale can confuse some algorithms. Feature scaling solves this problem. Two common methods are normalization, rescales values between 0 and 1. Standardization, centers data around mean equals 0 and standard deviation equals 1. Example concept. Different scales means feature scaling means balanced features. Algorithms like KNN, SVM, and neural networks benefit greatly from scaling. Step 6. Handling outliers. Outliers are data points that are very different from others. Example. Age income 305,000, 325,200, 355,100, 319,000. The last value is an outlier. Outliers may occur due to data entry errors, measurement mistakes, rare events. Example concept. Extreme values means outlier detection means corrected dataset. Handling outliers helps prevent models from learning incorrect patterns. Step 7. Feature selection. Not all features are useful for prediction. Some features may add noise, increase complexity, slow down training. Feature selection keeps only the most relevant variables. Example concept. Many features means select important features means better model. This improves both performance and training efficiency. Step 8. Data splitting. After preprocessing, the dataset must be divided for model training and testing. Typical split. Training set, used to train the model. Validation set, used for tuning. Test set, used for final evaluation. Example concept. Dataset means training data plus validation data plus testing data. This ensures the model performs well on unseen data. Data preprocessing pipeline. A typical preprocessing pipeline may look like this. Raw data. Down pointing arrow. Cleaning. Down pointing arrow. Handling missing values. Down pointing arrow. Encoding categorical variables. Down pointing arrow. Feature scaling. Down pointing arrow. Feature selection. Down pointing arrow. Dataset ready for ML model. This pipeline prepares data for machine learning algorithms. Example Python code. Example preprocessing in Python using scikit-learn. From sklearn. Preprocessing import standard scalar. Example encoding. From sklearn. Preprocessing import label encoder. Example splitting dataset. From sklearn. Model underscore selection import train underscore test underscore split. Libraries like pandas, numpy, and scikit-learn are commonly used for preprocessing. Real-world applications. Data preprocessing is used in almost every AI system. Healthcare. Cleaning patient data before disease prediction models. Finance. Preparing transaction data for fraud detection. E-commerce. Processing customer activity data for recommendation engines. Marketing. Preparing user behavior data for customer segmentation. Autonomous vehicles. Processing sensor data for object detection models. Concepts learned from data preprocessing. Understanding data preprocessing helps beginners learn. Checkmark how raw data becomes usable for machine learning. Checkmark why cleaning data improves model accuracy. Checkmark how categorical values are converted to numbers. Checkmark why scaling features is important. Checkmark how preprocessing affects model performance. Data preprocessing is one of the most critical steps in machine learning projects. Simple definition. Data preprocessing. The process of cleaning, transforming, and organizing raw data so that it can be used effectively by machine learning algorithms. Final summary. Data preprocessing is a key stage in the machine learning workflow. It involves cleaning data, handling missing values, encoding categorical variables, scaling features, and selecting important features. These steps ensure that machine learning models receive high-quality data, which leads to better predictions and more reliable AI systems. Understanding data preprocessing is essential for anyone learning machine learning, data science, and artificial intelligence.